Hello once again, ladies and gentlemen, and welcome back. We're looking at this video at B2 on our 2018 open paper. Let ABCD be a square with side length 1. 1's all over the place here. Points X and Y are on BC and CD respectively, such that the areas of triangles ABX, XCY, and YDA are equal. So all these areas are equal. Kind of interesting. Find the ratio of the area of AXY to XCY. Okay, all right. So, what can we do? Well, I suppose, the first thing I'm going to do is I'm going to draw a picture so that I can mark it as I see fit. So I notice I have a whole bunch of right angle triangles. So I got some ones here as, what were they? Is it A first? Yeah, A and then B, okay. A, B, X, C, D, no, D's down here. That's Y. Okay. So, knowing that AYD and ABX have the same area, kind of tells me that this length here should be the same. I don't know what it is. We could give it a name. I don't know, K. K sounds good to you guys? Yeah, K is fine. And then that means that we've got 1 minus K and 1 minus K over here. Now, the areas here can be worked out, 1/2 base times height, K, and the area here, thanks to it being a right angle triangle, can also be worked out, 1/2 base times height, but we're told that these are equal. So ignore the 1/2s. What we've got is 1 minus K squared is equal to 1 times K, which is K. So expand that out, 1 minus 2K plus K squared is equal to K. So 1 minus 3K plus K squared is equal to 0. We should be able to work out K from there, although I'm not liking that the product here, if I were to factor it, is 1. But certainly doable. Okay. Is there another approach to this that we could take? Well, I know that this area is K, I know that this area is K, and I know that this area is K, and that together everything adds up to the total area of the square, which is 1, because it's a 1 by 1 square. So this should be 1 minus 3K. Oh, there's a 1 minus 3K. 1 minus 3K is negative K squared. Oh, sorry, this is half K. Half K. Okay, there we go. That could have been very bad. It's because I got rid of the halves here. I wasn't careful. I was wondering why I suddenly got a negative number. Now it makes sense. So it's 1 minus 3/2 K. Okay. So what can we do from there? We're trying to find the ratio of this area to this area. Find 1 minus 3K over 2 to K over 2. I suppose we could, ratios are kept the same if you multiply both sides by the same number, so it's the same as the ratio of 2 minus 3K to K. 2 minus 3K is 1 plus 1 minus 3K, and now I can use this little bit of information. 1 minus 3K is negative K squared. I'll get 1 minus K squared. And now I'm not entirely sure where to go with this, actually. As I suppose we could try and express K with the quadratic formula, but I really don't think that that's going to end up being the best thing for us to do. I suppose we could. Am I missing something? Well, I suppose we know k is the same as 1 minus k all squared. This is a difference of squares, but I really feel like I'm going around in sort of a circle. But I'm going to divide by 1 minus k. So I'll get 1 plus k to 1 minus k. And again, I'm not happy with this. Am I missing something? Did I misread? Square, side length 1, points on the sides. ABX, XCY, YDA are all equal. Yep, I worked that out. So those are K, and that's K over 2, K over 2, K over 2. So that should be 1 minus 3K over 2. And I want the ratio of those areas. Yeah, off the top of my head, I can't see. Obviously I'm missing something. It's a B2, but what? I can't figure it out. Am I going to actually have to solve this thing? I feel like I'm going to have to work out what K is, unfortunately. I don't think there's any other way around it. I don't think I can use properties of K to bail me out here. So 1 minus 3K plus K squared equals 0. Okay, so negative B plus or minus square root of B squared minus 4AC all over 2A. So 3 plus or minus root 5 over 2. It's got to be the one that's less than 1. So we're going to be looking at 3 minus root 5 over 2 has got to be the K that we are specifically looking for. Okay, so then we're looking at a ratio of 1 plus 3 minus root 5 over 2 to 1 minus 3 minus root 5 over 2. I guess. So that's 5 minus root 5 over 2. That'll be 2 minus root 3 minus root 5, so root 5 minus 1 over 2. I was just thinking, my pause there was for a second was, should I have instead solved for 1 minus k and then tried to do something with that? Looks like 1 minus k is a much more familiar number. Root 5 minus 1 over 2 is about 0.618 something, I believe. Anyway, doesn't matter. Multiply by 2 on both sides. And, we can factor out root 5 minus 1, so root 5 minus 1. And so those canceling out, and it's root 5 to 1 is my final ratio. And I have to imagine there was probably some way to rearrange these properties to see that a little clearer. It didn't come to me. Maybe I should take a little bit of a pause before attempting B3. But we do have our ratio. Root 5 to 1. All right. And as I mentioned, next video, we will be doing B3. I think I'm going to take a little break, maybe grab a snack, but I will see you for B3 in the following video. Until then, take care.